Our study takes us to angular kinetics, and if you'll recall that when we classify movement, we talk of linear movement, we talk of rotary movement. When there are elements of both, we call it general motion. So linear motion, angular motion, and then the combination of the two is general motion. Our study of the application of force that causes rotation takes us to the force known as torque. Torque causes rotation, and here are some examples of this. You can find this portion of PowerPoint under Angular Kinetics, and I have that posted under Module 4. Might be worthwhile for you to take a look. So torque is the product of force times distance. When the force is applied at a perpendicular to the axis, or this is called the moment arm, from the axis of rotation to where the force is applied, there's going to be rotation. Here's the axis of rotation. Here's the application of force, and because it's at a perpendicular distance, it's applied to the moment arm, then rotation will occur. If the force is applied into the axis of rotation, there's no d, so it's F times 0, which will be 0. There'll be no torque. If the moment arm is shorter, so if this quantity, the distance, the perpendicular distance, if it's short, you'll have less torque. If F is smaller, you could have a long moment arm, but torque would be low. So to maximize rotation, have really large force applied at a right angle to the moment arm, and you'll get big rotation. The interpretation of this is it's easiest to initiate rotation when a force is applied perpendicular to the moment arm. Here's the axis of rotation to open the door. This little pup misperceived where the axis of rotation is. She's way over here at where the door is mounted on the wall, and she trying so hard, but her moment arm is too short. It doesn't have enough force, so she can't affect a good rotation to get the door open. This is really her circumstance. If she gets over here, closer to where the door opens, her moment arm is increased, the same amount of force, she has a good chance of opening the door. And then appreciating the fact that a mechanical advantage is gained through the use of lever systems. Classes 1, 2, and 3 levers represented for you in your hall textbook. The majority of lever systems in the body are third-class levers where the axis of rotation, the fulcrum, and the resistance are on opposite sides of the lever, and the force driving the resistance is in between the fulcrum and the resistance. This is a great lever for achieving speed. This is kind of a catapult operation where we can generate great speed and range of motion, but it's not a great lever for producing really high force. Again, you can find this PowerPoint under Module 4 under Angular Kinetics. Hope that's helpful to you. Bless you.